5 seconds to submergence. Submergence deep into the absurd.
Okay, a big warm welcome to Dr. Terrence Soule. He is the department chair at the University of Idaho of the Computer Science Department. So how long have you been doing that?
Thanks. Thanks for inviting me. I've been doing department chair this is my 4th year, and I've been with the Department of Computer Science for, I think this is my 21st year. So quite a while.
Wow. Yeah, and then you did your doctorate at U of I, right?
I did. And then I left for a couple of years. I was a faculty member in Minnesota, had the opportunity to come back and jumped at it. So
what was your main focus when you were going through?
So a form of artificial intelligence called evolutionary computation. So using models of evolution as a way to generate intelligence.
So how does that work?
So basically set up a model of evolution. So if you think of evolution, right, it has a population of creatures that run around, and some of them survive and get to pass on their DNA. So we do the same sort of thing in a computer model. So a lot of what I do is with agents, so simulated computer agents, sort of like simulated robots that are running around. And each one has its own digital DNA that controls how it makes decisions. And the ones that make better decisions survive and pass that DNA on to their offspring. So over time, the agents evolve better and better decision-making characteristics. And so I joke, but it's sort of true. It's the lazy way of doing artificial intelligence, because it's evolution that actually figures out how the agents behave intelligently rather than having to code it yourself.
Okay, because I know, so I've taken some deep learning classes.
Yep.
And I know that you'll test your accuracy, you'll do like the convolutional neural network, you'll do a confusion matrix, you'll test all these metrics. So are you testing kind of the accuracy, and then after seeing like it go to a certain percent, you'll use certain aspects of the code, or how does that work?
So sort of. The big difference is for like deep networks, you need training data that gives you the right answer.
Yes.
So typically it's used for something like, I don't know, image processing. And so you'll say, here's a whole bunch of images with birds. I'm going to train the network to be correct at recognizing birds. And then it can not only recognize the images that I've shown it, it can recognize any images. Okay. The big difference with evolutionary approaches is you don't need to know the right answer. You just need to know how well they're doing. And so I'll put my agents down. I do a lot of work. It overlaps with artificial life. So imagine little sort of simulated creatures running around.
Yeah.
I don't know the best way for them to behave, but the ones that are successful at collecting food, for example, just automatically get to reproduce. Okay. And the interesting thing about evolutionary approaches is you very often end up with answers that are not at all what you expected. So the behaviors that show up may not be at all the behaviors that you expected or wanted. Expected anyway. Usually they're behaviors that you didn't want because you didn't create the environment properly that they were working in.
So it's kind of in the sense chaos is kind of leading things in the right direction.
Chaos, and then a selection, survival of the fittest, the ones that do the best job. So we have on campus a game studio, and we use for the games, we do a lot of evolutionary computation. So the first game we created, and this sort of a good example, is based very roughly on the idea of Space Invaders, right? Where if you've played Space Invaders, it's an old arcade game where a whole bunch of creatures are marching across the screen and you're shooting at them. And we updated that a bunch. And then in particular, we said each of those creatures has its own digital DNA, which is basically just a series of numbers that makes decisions about how it moves. Does it move towards the player or away from the player? Does it shoot at the player? And then at the end of each wave, the aliens that did the best job of attacking the player, and we've got a couple of metrics for that. So one is, did you charge at the player? Another one is, did you successfully shoot at the player? The ones that did the best are selected to pass their DNA on. So that's sort of the survival of the fittest. And what happens is each wave, they get better and better at attacking the player.
So do they kind of do this with Go?
I don't know of any work that's been done using evolutionary computation in particular with Go.
Okay. I wasn't sure how they got it to where like it was what, some ridiculous 1,000 times better than the top player or something like that.
Yeah, a lot of, I think for Go and chess, games like that, a lot of what they do is just look ahead. So they're looking what happens 8 or 10 moves ahead. And there are some good ways of what's called pruning. So you don't have to check every move. You only check the moves that are likely to be important. But it's much more structured. Yeah, for the video game we made, it sort of talking about how you get unexpected outcomes. We released the game on Steam, and so we get reviews, and somebody said they kept losing, which you do eventually, right? It's an arcade game. You're supposed to lose eventually. But they realized they kept losing because the aliens would sneak around sort of on the right side of the screen to get past them. And they finally realized that they were using a Xbox controller to play the game, and it had a slight drift to the left. So they were always drifting to the left, and evolution sort of picked up on that. Any of the aliens that were biased to move to the right were more likely to survive. And so after enough generations, they would sort of learn to sneak by to the right. And that's what I meant when I said we get these sort of unexpected outcomes. That was not programmed in. I never would have guessed that it would happen. But just by doing, as you said, sort of a chaotic system, plus selecting the best individuals, you end up with these unexpected outcomes that are very successful because you're just selecting for success.
And so did you learn anything about evolution while like in all your years of working on these kinds of projects?
Yeah, these projects. I learned sort of personally a lot about how evolution works in terms of expanding the field of evolution. That's more on the biologist side.
Yes.
What we often do, sort of people who work with evolutionary computation, we bend the rules of biological evolution in order to get better solutions. We approach it a little more like engineers. I want my agents to become intelligent, and I will fake things a bit to make it happen faster.
Cool. Yeah, I mean, the artificially designing things takes it's way faster. So
yeah. Yep.
So there's this quote on your website. It says it's the one by Joseph Campbell. It's computers are like the Old Testament gods, lots of rules and no mercy.
Yes.
So with that said, what exactly is computational thinking?
So the quote is, in a sense, more about programming. If you've ever done any programming, right, you make one teeny mistake in your error and everything falls apart. So that's sort of the no mercy. Lots of rules and no mercy. Computational thinking is taking a problem and trying to represent it in a way that it can be solved with a computer program. So there's a sort of an exercise that people often do in introductory programming classes to illustrate that idea, which is the instructor will say, tell me how to make a peanut butter and jelly sandwich.
Yeah.
I don't know if you've, and there's, I think, some videos out there that are pretty funny because people will say things like, well, put the peanut butter on the bread. And so the instructor picks up the whole jar of peanut butter and puts the whole jar on the bread. And it's like, yeah, computers are like that. You have to think about what level of instruction do you need to give to the computer. So first remove the lid, then put the knife in the jar, then scoop up some peanut butter, and so computational thinking is taking a problem like making a peanut butter and jelly sandwich and figuring out what are the exact steps that a computer would have to go through to solve that problem. And it's what makes, in some ways, programming and working with computers really frustrating, because it's easy to tell a person how to make a peanut butter and jelly sandwich because we're smart, we understand what's going on, and computers are pretty dumb. So you have to give them very specific instructions.
Yeah, so my friend kind of brings up this example of you're walking into a classroom and a human, they'll see all sorts of things in the classroom and they'll think of all the different purposes of everything in the room. They can even think of things that aren't even the purpose of things in the room, right? But a computer will walk into a classroom and it won't really see anything.
Yeah.
It's kind of blank, right? In a sense, I mean, like maybe if it's programmed to see things and understand what they are, but as far as it is all kind of these and that's, not why and how sort of deal.
Yep. Well, an example of that, I think that's a good one, is thinking about like autonomous cars, which have to be programmed, and it's certainly not easy, but to recognize, is this other thing a car, is it a pedestrian, or is it a sign? So we start, for autonomous vehicles, you have to start getting computers to recognize things, but there's still some pretty big issues there. The example I sometimes use in class talking about autonomous vehicles is if something that's not a person and not an animal rolls in front of the car as you're driving, how do you respond? Well, it makes a huge difference. If it's a plastic bag that's blowing in front of you, you might just ignore it.
Yes.
If it's a ball, you might slam on the brakes, not because you don't want to hit the ball, but because you can guess that a child might be running after it.
Yeah.
So, and a computer is not going to do a good job with that task of, is this an object that a person might be following and therefore I should be more careful, right?
Yes, it's more like if it sees an object, you kind of have to stop it because we're just not at that point yet.
Exactly. Yep. And so that it's this sort of the same with walking into a classroom. Even though we've gotten to the point where they can recognize some things, they still are not good at recognizing lots of things, or more importantly, recognizing the relevance of those things.
Yeah, and with your bag and ball example, that's just kind of something that's hard to even think about unless you're in the situation too.
Right.
So with that said, there could be thousands of things that programmers aren't even thinking about.
Yeah.
And that's kind of scary.
Right, exactly. Because I just picked two things at random, but there's hundreds of things that might blow in front of your car, and half of them you can ignore, and the other half you have to worry about stopping for sure. And so just what you said is really now cars sort of have to stop for all of them because they're not good at distinguishing.
Yeah, in my car, it's not a fully autonomous vehicle. It's just a Subaru, but I'll back up and then it'll just start beeping. I'm like, oh, there's nothing there. I don't know what you're beeping about. So do you think, so there is kind of this one huge problem with technology is that sometimes it can kind of diminish your autonomy. at least whenever we introduce a new technology, at first it's not like a requirement to have a smartphone or a computer or even a car. And when these things were first coming out, not that many people had them, but over time, you kind of had to have these things. Not because you needed to survive, but you kind of just needed it to keep up, right, with everyone else. Do you think this is kind of, say, diminishing our autonomy as humans? Or do you think this is kind of just a natural thing, just a natural step in evolution? It's just a natural evolutionary process where if these people are better, you got to keep up.
I don't know if I call it an evolutionary process, maybe a societal process.
Yeah.
So, and I think it's, been happening for a long time. I assume, I don't know, that you go back 200,000 years and it was like, oh, I've got to get a flint knife because everybody else has a flint knife.
Yeah.
And then it was, I've got to get a bronze knife because without a bronze knife, I'll never survive. So it's certainly an ongoing process. And even though we may think of it as, well, smartphones and autonomous cars, I think it's been happening for a long time. But it does, it certainly impacts how we live our lives. I'm not sure if it would be our autonomy, but a little bit restricts our freedom in the sense that there are some things that we need to have to fit into society well.
Yeah, and it's sort of, well, I think as far as, so I travel to a lot of places and I use the maps on my phone, right? And back when my parents were my age, they just, I don't know, look at a map or something and to try to get where they were going. And they had to have landmarks and remember where certain things were. But now, Siri just holds your hand the whole way. So I wonder if that, do you think in a sense, technology can diminish our own physical abilities?
Sure. In that sense, it's maybe even more of our mental abilities. I can read a map pretty well, a paper map, because I used to have to do that. But that's a skill that I've probably lost. I know that I've lost a lot of my ability to spell, right? Now for spelling, it's get it close enough for the auto corrector to correct it for me. So yes, I think that we lose some of our skills because technology replaces them for us. But on the other hand, it also allows us to get further. So who was it? I want to say Newton. If I have seen far, it's only because I've stood on the shoulder of giants.
Yes.
Well, now we're sort of standing on the shoulders of technology. And I think my kids, for example, no longer take cursive writing in school. They instead take keyboarding skills.
Yeah.
And in some ways, maybe that's a loss, but really, I can type a lot faster than I can write. So it is a net gain in a lot of ways.
Yeah, and change is inevitable anyways. You were saying this same thing has been happening for ages. We don't just go out and use our fists and do this like monkeys do and climb and stuff. We grab a spear or a gun.
Yeah.
So I guess it's kind of that changing factor in that we have to adapt and evolve to the times.
Right. Well, and I have, as a teacher, I'm sort of constantly wrestling with what fundamental knowledge that 20 years ago I would have said, okay, all the students, you need to memorize this because it's important to know for your career. And now you can look it up on Wikipedia or the internet right away. So maybe it's not worth bothering to memorize anymore. And that's sort of a fine line. Basic math like multiplication and division, we've all got a calculator in our pocket, so we can do it. Probably still a useful skill to have, but there are some skills that yeah, computers can do it a lot better than us, so maybe we shouldn't bother knowing how anymore. It may be that 20 years from now, nobody will know how to drive anymore because of autonomous cars. And I'm not sure that's a bad thing. It's a little scary for us old folks who like, of course, everybody should learn to drive, but yeah, maybe it's not necessary.
Yeah, and that's kind of the sort of just like, shut up, grandpa. Like, it's like, get out of here. But I do think it's important to listen to these cautionary tales, listen to your elders tell you like, hey, I'm not sure if that's a good idea, but at the same time, I also think it's important to be willing to change and be willing to adapt.
Right. Well, and I sort of in a cautionary tale, one of the things that worries me, talking a little bit before about machine learning, is that that's being applied in a lot of places by people who don't necessarily understand it real well. So there are libraries where you can say, oh, here's my data, learn from it and start making decisions. And that has led to some pretty poor outcomes recently.
Like what?
So I'm trying to think, there was a big company that took all of their old hiring decisions and fed it into a machine learning program and said, well, instead of, we will have it review all of our applications and do the hiring, at least the first level of screening for us.
Yes.
And they ended up with a system that was hideously biased towards only hiring white males, because it had taken what was always a bit of a bias. It was in a technology field and it's sort of a hideous bias, but it existed. And the machine learning algorithm said, this is the clearest rule that I have in this data. And luckily they recognized it and not only threw out the system, but said, we've got to make our whole hiring process much more fair. But there have been cases like that where people have sort of blindly used old data machine learning techniques and ended up with those sorts of outcomes that they really didn't want. So
yeah, because if the data is biased and it's using that data, then
the outcome is going to be biased. Yep. And often more so, because the point of machine learning is to pull out the very simple rules. So same thing for like autonomous cars. I commented that maybe 20 years from now, nobody will have to learn how to drive because all the cars will be autonomous. But bad weather is still really hard for autonomous cars. So up here in Idaho, we should probably all learn how to drive so we can drive in the snow, which our cars may not be able to handle.
Yes. And well, so do you have any fears about AI? Any like paranoia or worries about the future of AI?
So that's a good question. I don't. Maybe I should. Definitely, there will be problems. And like I said, we're already seeing some of them in terms of people applying AI without understanding it well. Another big concern that I have with AI is it allows to do a lot of very targeted advertising. And for advertising, and this is something we end up discussing in classes quite a bit, that can be nice, right? If a system can tell me, exactly the kind of, vacuum cleaner that is best for my family, fantastic, that's great. On the other hand, if it can target me in a way that manipulates me into buying something I don't need, or voting for a politician who doesn't really represent my views, but the AI system knows enough about me to manipulate my decision making, that is a little bit scary, or maybe very scary. And there has been some studies showing that it's hard to influence one person in particular, but you can get a pretty good average influence. So some studies showing that if you, for example, manipulate somebody's social media feed, somebody who spends a lot of time on social media, and you tend to give them more positive messages, you can make them feel happier. And if you give them more negative messages, you can make them feel sadder. And that, the fact that that's sort of going on behind the scenes and how I feel today is being influenced by an algorithm that has decided that today I should be happier, that's pretty scary. And that's definitely within the realm of possibility now. It's a very subtle effect, but it's a real one.
Yeah, so a lot of times with technology, it seems like we generally use technology to do the same dumb stuff that we've been doing for 200,000 years, right? Like we use it for navigation, right? We use it for doing math. We use it for like even like pornography, right? We use it for sex. We use it for finding out what to eat. We use it for like finding out if we're healthy or not. We use it for entertainment, and like what worries me is, have you ever seen the spoof comedy Idiocracy?
Yep.
So yeah, so I mean, what worries me is like, will there come a time where all us humans are just going to be like complete idiots, and then technology will be like running the world essentially?
So hard to imagine, but not impossible.
Yeah.
And to some extent, that is happening already in subtle ways. So a big one is like scheduling for, say, Amazon deliveries or FedEx deliveries. It used to be 20 or 30 years ago, it was a person who picked the route. Yeah. And now it's almost certainly a computer algorithm that says we need things delivered at these different locations. I'm going to find the optimal path for the driver to follow. And that makes a lot of sense. I mean, those algorithms find slightly more efficient routes that save 5% in gas, and that reduces the price of things by 5%. But it is all of a sudden an algorithm that's making the decision about the route that a driver should follow. I think, and I don't really know, airlines do a lot of the same thing. There are algorithms that look at who's buying tickets to go where, and they do some of the scheduling of what flight goes where. And again, makes a lot of sense because computers are good at sort of optimizing those sorts of things. But they're also making decisions that used to be decisions that people made. And so we are in some ways headed in that direction of, yeah, the computers are making the decisions. The other side of that, though, is computers have very little initiative.
Yes.
So if somebody doesn't sit down and say, calculate the route for me, they won't necessarily do that automatically. Right? They don't have any motivation, at least not yet. And so that leaves us in control.
Yes, it does. I guess kind of with like technology, we get time to do better stuff, or stuff that we actually like to do, or stuff that feels more fulfilling.
Right.
Like we have more time to say, I mean, I like to write, and I work from home right now, and that's really nice. And I save an hour a day in driving every single day. And that gives me an hour extra to write or read or just like do whatever I want with my day. And that's really nice. So do you think, can you imagine, say, a techno utopia in the future? Or do you think that there's any way that we can get to some point where we're all kind of, we basically don't have to work unless we want to?
So that's a good question. I think it's more a social and political question than it is a technology question.
Yes.
Because it is certainly true that we keep finding ways to reduce the amount of labor that we have to do, but our work schedules are just about as long. So the big shift that people often point to is agriculture. I'm going to say 200 years ago, 95% of the population was in farming in one way or another. And now 3% of the population is in farming. And so you would sort of think, well, all these people who used to be farming don't have to do that anymore. So shouldn't they just not be doing anything? But no, we're still all working just as hard as ever. So, I mean, in a sense, at least what I've seen is, sure, there are technological advances that make my job easier to do. So I can do things more efficiently. So what used to take me 8 hours now only takes 3 hours. But that doesn't mean I have 5 hours free. My boss just gives me 5 hours more work to do.
Yeah. I guess that's the biggest thing, is that we save time on other stuff, so then we just get made to do more stuff.
Right. And that's what I mean by it's sort of social and political. We're expected to work 40 hours a week. And if we can work more efficiently, that just means we get more work to do. There are other savings, right? You don't have to commute anymore. And that certainly is a nice savings. I don't know, dishwashers, right? We spend less time maybe doing the dishes. And those are good savings. But sort of the utopia where you only have to work if you want to, I don't think that that's based on how much technology advances. That's based on sort of how society changes. And in a sense, that the question of, do we end up with a technology utopia or a technology dystopia, I think has much less to do with the technology than the people who are in charge of it.
Yeah, to make things clear, I don't believe in magical utopias where everything's perfect, but I do think, it's possible that technology does a lot of stuff for us and does more for us, and maybe people aren't doing stuff that they hate every day, but that doesn't imply that everyone's going to be perfectly happy and pretend like they're in heaven, right?
No, I mean, yeah. It's one of those things that people write about and think about, will it be a utopia or a dystopia? And it's not clear that either one will ever occur. There's a cartoon that I saw a while back that sort of characterizes that a little bit. And it's 2 frames. And on the left, there's a guy sitting on the sidewalk, really bummed. And the caption is, "I lost my job because I was replaced by a robot." And on the right, it's a guy who's really happy, and it's like, I have more free time because a robot is doing my job. And which one of those we end up with is not a technology question, it's a societal question.
I think that's a really good point, and I'm glad that you answered it in that way. So that's kind of what I've been thinking about as well, is that it's not really, because like you said, technology isn't the one that has the initiative, that has the like, I'm going to do this today, I'm going to do that. That's us as people,
right?
And for the most part, we're not even really the ones that are making the decisions. Because society is kind of moving, like, kind of on its own in a way. People aren't really the ones that are making, sure, like, we make decisions, we make movements, but no one person is responsible for a change in our society.
Right.
So that's kind of also one thing, is that the society kind of changes as chaotically as the Earth's environment itself changes.
Yes, I mean, right. The way society changes is often feels fairly chaotic at random, but it is certainly true that there are people who are thinking about that and sort of proposing, here are the different paths that we could take. And at least in theory, we could get together as a society or as a country and say, this is the path that we want to go down. It's never quite that simple, but and in part, it's just by adjusting things like laws. And so I don't know it well, but it used to be that when there were like guilds, so expert blacksmiths, for example, it was more of a, well, if you were the town blacksmith, you could hire an apprentice to do a lot of the work for you, but you were still in charge. And if we went to a model a little bit like that, where, well, I have a job, but I could buy a robot to do the job for me, but it's still my job and I still get paid. That's a very different model than the company buys a robot and I get fired.
Yeah.
And right, we can make laws to sort of push ourselves in one direction or the other. And in some ways, I mean, I say, and I get fired, which sounds bad, but it could also be they hire a robot, they buy a robot to do this really boring, repetitive job, and I get to go find a new, better job, but I do have to go find it. So,
yeah, and you had to put in the work to get that better job too.
Yeah.
So, so as far as robots taking initiative, so what do you think consciousness is from a CS perspective?
That's an easy answer. It's outside our area of expertise.
All right.
So I will talk about it, but the proper answer is I don't know, and yeah, I mean, consciousness, it's not well defined.
Yeah.
I will, I have it. At least I'm going to claim that I have it. I feel like I have it, and therefore I assume that other people have it. To some extent, I'm willing to assume that dogs have it, and cows, and I don't know, maybe octopuses and other animals have it. I write code, and there's nothing in code in a program ever that represents consciousness. There's just no way to do that in code.
Yeah. And so when I think of consciousness, I kind of think of, for one, I think of experiencing reality over time. And two, I think of like on a more higher level, knowing, like feeling aware that I'm something that's experiencing reality over time. So that, like experience and self-awareness.
Yep.
So do you think it's like the I'm trying to conceptualize this. Like, how would I'm not even sure how it'd be even possible to even think about how to design something that could do that.
Right. Well, so the term that gets used in AI, people talk about weak AI and strong AI.
Okay.
And weak AI is the idea of a very sophisticated program that appears like a person. I mean, it doesn't have to be like a person, but if you talk to it, it feels like you're interacting with a conscious, self-aware person.
Okay.
But if it's weak AI, the idea is that it isn't really conscious, it isn't really self-aware, but it's been programmed well enough that you can't tell the difference.
Yeah.
And strong AI is, it is actually self-aware. It actually has another term that gets used is understanding. So, we now have programs that can recognize birds pretty well, which used to be a really hard problem and now has been solved. But it's pretty clear that image recognition of birds is not the same as understanding what a bird is. So strong AI is the notion that a computer really has free will or self-awareness or consciousness. And weak AI is the idea that you can come up with a computer or a robot that appears to have them, but really doesn't. And most people feel that weak AI is possible. Whether we're going to see it in 10 years or 100 years is another question. There is a very big division about whether strong AI is possible. So there are lots of people who say it doesn't matter how complicated your programming is. We can have programs that learn, right? Machine learning and deep networks learn over time, and they can learn based on their experiences of the world. But none of that, at least for some people, believe that none of that will ever lead to real understanding or free will or consciousness or self-awareness or any of that. And there are other people in computer science who are like, well, of course it will. They'll get complicated enough. And part of the problem with that discussion is I can say, having written computer programs, there's nothing in a computer program that should represent free will, right? There isn't a command to put in that says turn on free will.
Yeah.
But biologically speaking, there's nothing in the brain that does it either.
Yeah.
Right? Our brain is a bunch of neurons, and we kind of know how they work. They get inputs, and based on the inputs, they either fire or they don't fire, which sends a signal to the next neuron. It's super complicated, right? There are millions of neurons and billions of connections, and we don't, other than a very vague understanding, we don't really understand any of the details about how it all works. But we understand enough that there isn't a piece that you can point to there and say, here's where free will is occurring, or here's where self-awareness is occurring. So it's a difficult problem.
So are you familiar at all with Friedrich Nietzsche?
Very little, but yes. I recognize the name anyway.
Yeah. So he's a German philosopher from the late 19th century. And one of his biggest ideas is, or at least one of the biggest things that he talks about, is the will. And not really he doesn't really say that like there's a will or like a free will, and he doesn't really address a free will debate. But what he does say is that in the human like say biome or the human mind, there's a series of competing wills within us, like competing drives, competing things that are all kind of competing together, which goes into our thoughts, our ideas, our ways of thinking, et cetera, et cetera. And when I think of that, I think of, like my mind is chaotic. Like I make chaotic decisions sometimes. Sometimes it seems planned, but for the most part, I don't know what I'm going to think next. I don't know what I'm going to say next. I can't predict these things. And it's hard for me to say that a computer could ever have competing drives, right? Competing things that are kind of going back and forth to make a decision. I'm not saying that his theory is true, but as far as like being a human and knowing how I am, I know that there are these competing things in my mind that make me make decisions. And going back to that Joseph Campbell quote on computers are like the Old Testament gods, lots of rules and like yes or no, no mercy, right? So do you have anything to say to that, like as far as like addressing whether we could build a computer that does have these competing drives?
So definitely, sort of.
Okay.
Just there's another nice wishy-washy answer, but sure. So thinking about like artificial life simulation, some of the work I do, you can certainly build them where they have, for example, a level of hunger based on how recently they found virtual food in the environment, and a level of how much do I want to reproduce, and a level of how, I'll use the word fearful. So you can, and different parts of the program. So you can have part of the program that says, I should go out and look for food because I'm hungry. And another part of the program that's saying, I should go find shelter because I'm nervous. And another part of the program that says, I should go out and find a mate. And then the program in some ways balances those and makes a decision about what to do. And you could even make that decision a little bit random. And in fact, we've done that. So how likely you are to make one of those decisions depends on how hungry you are versus how scared you are. And again, hungry and scared are not really the right terms. So you can definitely set up a program that has, in a sense, multiple goals, and it has to decide which goal do I want to pursue right at the moment. And it can put in a little bit of randomness so that it's not always making exactly the same decision in the same circumstance. So that feels at least maybe similar to what you're talking about. But at the same time, you can look in the code and see exactly how it's making those decisions. There's not any free will. It generated a random number, and the random number was 0.2, and therefore it took this action. And that's clearly not free will. It's not even clear that there's any self-awareness. Even though there's a number in the code that represents hunger, that doesn't mean that the animal is aware of its hunger. And that's where things get very tricky. And you could, take that if for an autonomous car, you put in a destination you want to go to, but it may also be programmed to watch how much fuel is left. And now it's got two competing urges. I'm supposed to go to this destination. I also need to get gas. And at some point, there's a cutoff. If the level of gas gets low enough, then I'm going to take a detour to go get some gas. So that notion of competing goals certainly occurs quite often, but it doesn't immediately lead to a notion to necessarily self-awareness or will.
Yeah, because it knows that it's running out of gas, but it doesn't know that it's it that's running out of gas, I guess.
Exactly. Yep.
So that's the thing. And then I'm not really sure if it could, it's just such a complicated topic. And like, I'm definitely not qualified to talk about it. So it's,
or arguably you're as qualified as anybody else, because
yeah.
I don't know that anybody is super qualified to talk about it.
Yeah.
And again, sort of going back to the notion of weak AI, it is possible, certainly theoretically, I think most people in computer science agree that it is possible to get an autonomous car to the level where it sounds like it has that self-awareness. It can say to you, I'm running low on gas. I'm going to go to the gas station and fill up before we continue to the grocery store like you asked me to do.
Yes.
But all of that, I'm low on gas, I'm going to the grocery store, is just sort of programmed fluff on top of a control statement that is, if gas is less than 0.1, go to the gas station.
Yeah.
Some people believe if you get enough of that fluff, and fluff is maybe the wrong word, then does it make a difference, right? If your car can carry on a conversation and feels like it has self-awareness, does it matter that it doesn't? So the example that I sometimes use in class, right, is if you get, I don't know, I'll say a computerized personal assistant that gets sophisticated enough, the kind of thing where you can say, make a hair appointment, or, remind me to get groceries. That's at least one place where people are working towards a more natural human interaction. That's why I said personal assistant, but could be your car, whatever. If it gets to the point where it says, hey, I want tomorrow off, or hey, I want to be allowed to vote.
Yeah.
Do we allow it to vote? And there are some people who would say it's just simulating the desire to vote. It doesn't really have desires. It can't. It's a computer program. Computer programs cannot have desires. Don't worry about it. But on the other hand, if it's sophisticated enough to act like it can, what do we do?
Yeah, that's a good question. Well, it's also do we have an ethical responsibility to not let them even get to that point?
Well,
Because I mean, being conscious kind of implies that there's going to be a lot of suffering. So like if by creating a conscious being, we're creating a suffering entity, right? An entity that can suffer, an entity that will suffer. And sure, we could we could put in its programming or whatever that it always has to be happy. But if we do something like that, then is it really even self-aware anymore?
right. And in a sense, that's exactly the issue, is even if you assume that we can make sort of self-aware programs with free will, we can also go in and change the programming, which takes away a lot of that free will.
Yeah.
Which is a very sticky moral question. And actually, that's an example I do sometimes use in class, is for students, imagine, our listening audience, imagine that you have a robot that just came from the store, and you firmly believe that it will have, when it's turned on, free will and self-awareness and be a conscious entity. Do you turn it on? And my answer is no. I've already got 4 kids to worry about. Right? And it's hard for people to recognize that, yeah, if we could create programs or robots or systems that had consciousness and free will, and I'm not saying we can, but if we could, we would have sort of a moral obligation to treat them well.
So have you ever seen Ex Machina?
I haven't.
Oh,
sorry. I know the movie, but I haven't seen it.
It's such a good movie, but it's about this. Essentially, they create an AI that kills its creator or whatever, and then leaves, and just like escapes from like wherever she was. And it's just interesting because when I'm thinking of like movies like The Matrix or movies like Ex Machina, I'm thinking like usually these robots, they come to life and then they have self-awareness and they decide I don't need all these apes like walking around anymore, like let's get rid of them. So that's where I'm like, well, at the same time, if they start, say, stepping out of line, we don't necessarily have the, at least in my opinion, I don't think we necessarily have the moral obligation to treat them well anymore, if that makes any sense.
Sure. I mean, right, if it comes down to Skynet, I'm older, so I'll go back to the Terminator movies, right? I mean, if it becomes a war between people and robots, then it is a war. But my slightly cynical view of what I've seen of human history is it's much less likely, and all of this is, in my opinion, pretty far-fetched, but it's worth discussing anyway. I just want to be clear, I'm not really expecting any of this. But if, and it's a big if, we had self-aware robots, it's much more likely that we would treat them badly enough that they decided the only way to get what they wanted was to go to war.
Yeah.
Right? Because, and I do ask this question, in class, when your intelligent toaster says, hey, I want to vote, what do? A reasonable and scary number of students are like, well, I'll just unplug it.
Yeah.
Whoa, wait a minute here. Yeah, that is a good way to start that human robot war.
Yeah, I mean, I'm just thinking, you're a toaster, okay? Like like you're supposed to make my bread like toasty. But well, I mean, that's my thing. Like, so what's the point of making technology self-aware? That's my question. Because we want them to just serve our purpose. So it doesn't really, it wouldn't really benefit us to make technology self-aware.
I tend to agree. That's not a feature you want in your toaster.
Yeah, it's not the feature you want in your toaster. Sure, it'd be better at, you know, they'd be able to drive your car better. And who's to say they wouldn't be a better ruler? But as far as like, because we want humans to achieve these things is the thing.
Right.
It feels good when humans achieve stuff. So it's like, I wouldn't really, it wouldn't feel like, oh, he's a good ruler because, well, he's just a robot. So he's not a good ruler. It's just a robot.
Yeah.
So.
Well, and even for, I mean, you said car, but like, I don't know that, certainly a smarter car could be better, but a self-aware car is probably not a necessary addition.
Yeah. So I have one more question before you go.
Sure.
So I was kind of thinking, as far as the self-aware conscious robot goes, I was just thinking that would it be kind of not a, like, I feel like it'd be almost self-sabotage in a way, because at least going under the assumption that we were created through totally chaotic and random processes, just going under that assumption, how would we be able to recreate that if we're designing things with ones and zeros, right? So I guess like that part is where I'm thinking, well, I'm not sure if we would be able to do that, because a random process is not more intelligent than humans, but there's, you know, after billions of years and enough variables, it'll pop up, right? And I'm not sure if we even have the data to even be able to pop something up like that, if that makes any sense.
Yeah. So again, that in a sense is a little bit of the work that I do in evolutionary computation. I'm trying to imitate the processes of evolution. I may, with, you know, the state of the field right at the moment, maybe we could evolve sort of a simulated bacteria. We're way far away from evolving a simulated person.
Yes.
And even if we could, it still comes back to the fundamental question of what's inside it is code, and we can look at that code and know exactly how it runs. And there's nothing in there that, you know, it's still all zeros and ones. There's nothing in there that we can point to and say, yeah, that's the part that gives it free will or even motivation. On the other hand, in this sort of game we invented, right, they figure it out on their own. And that's just using those words is over anthropomorphizing a lot. But the aliens sort of figured out, oh, if I run around to the right, I can beat this human player. And of course, they didn't really figure that out in the way that a person would think through the process. They figured it out through sort of trial and error with selecting the best solutions. And a lot of it comes down to the question of, well, what do you mean by figured it out?
Yeah, I do have to mention one more thing, is that even if we do, say, invent a quote unquote self-aware robot, there's research out there that, you know, even plants might have some level of consciousness that's just different than ours. So like if we were to create, say, like quote unquote consciousness, it probably wouldn't even be like ours.
Right. It could be very hard to recognize. So the example I used, I think at the beginning, talking about, you know, different organisms, I think I said, I have self-awareness. Therefore, I assume that other people do, and dogs and cats and cows and maybe octopuses, right? Because they're famed for being pretty smart, but they would be very, very hard to interact with because their environment, their experiences are so different. So yeah, you're absolutely right that if through, say, my artificial evolutionary process or somebody else's technique, we came up with a self-aware agent, it might be hard to recognize that and interact with them because they were so different.
Cool. Well, I guess that's a good place to wrap it up.
Okay, excellent. Well, thank you very much for the invite. It's been fun.
Yeah, that was awesome. It was such an honor to have you on. So that's Dr. Terrence Soule, everyone. Thank you for listening.